Imagine a rock the size of a stadium hurtling towards Earth at 65,000 kilometers per hour. If we spot it too late, there is nothing we can do. But if we spot it 10 years in advance, we have a chance. But here's the problem. How do you stop a mountain moving at the speed of a bullet? You don't try to blow it up. Hollywood got that wrong. If you blow it up, you just turn one cannonball into a shotgun blast of fragmented debris. The real solution is physics. Speed is orbit. If you can slow an asteroid down by just a few centimeters per second, its orbit shrinks. It arrives at the intersection with Earth just a few minutes late. And in the vastness of space, being late means missing us entirely. This is the theory of kinetic impact. It sounds simple on paper, but until recently, it was just a theory. On September 26, 2022, NASA decided to stop guessing and start testing. They launched the DART mission to slam a spacecraft into a living asteroid. But what happened that day didn't just prove the theory, it revealed a terrifying secret about the asteroids lurking in the dark, a secret that changed everything we know about planetary defense. To test a planetary shield, NASA needed a shooting range, but they couldn't just pick any rock in the sky. The target had to meet two very specific criteria. They found the perfect candidate in a binary system called 65803 Didymos. The system consists of a large parent asteroid and a smaller moonlet orbiting around it, named Dimorphos. First, the setup. Because Dimorphos orbited its parent exactly once every 11 hours and 55 minutes, it acted like a precision cosmic clock. By hitting the moon, NASA aimed to shorten that orbit. If telescopes on Earth saw that 11-hour cycle change, we would have immediate, undeniable proof that we moved it. But the second reason was even more critical. Although they hadn't confirmed it yet, scientists highly suspected that Dimorphos was a rubble pile asteroid. This distinction is vital. A rubble pile is not a solid rock. It is a loose collection of boulders, gravel, and sand held together by gravity so weak it barely exists. This lack of internal cohesion changes the fundamental rules of impact. In a solid object, shock waves shatter the lattice. In a rubble pile, energy dissipates through friction and rotation of individual stones. If Dimorphos were a sand pile in a vacuum, a standard kinetic impact might fail to deflect it. Why does this matter? Because the vast majority of asteroids that pose a real threat to Earth are believed to be exactly like this. They are flying gravel pits. If we're going to save civilization, we need to know, what happens when you punch a cloud of rocks? Does it move? Or does it simply swallow the spacecraft like a crash into a sand dune? NASA needed a target that represented the real enemy. Dimorphos was that target. The DART spacecraft was a robot on a suicide mission, and for the final 4 hours of its life, it was flying blind. At 11 million kilometers from Earth, the signal delay was nearly 40 seconds. No human pilot could guide it. DART had to think for itself. It relied on a system called SmartNav. In the vast darkness of space, this algorithm had to perform a high-stakes magic trick. It had to ignore the massive parent asteroid it had been tracking for months and lock exclusively onto the tiny moonlet, Dimorphos. This was the moment of highest risk. If the computer got confused by a shadow or a reflection, it would send the spacecraft sailing into the empty void between the two rocks. But the lock held. As the spacecraft closed the distance at 6.6 kilometers per second, the camera revealed a landscape of nightmares. It wasn't a smooth, solid surface. It was a chaotic graveyard. The surface was littered with egg-shaped boulders, some as large as houses, resting precariously on top of loose gravel. Every pixel sent back was a map of ancient violence, showing a surface never touched by wind or rain, only the slow, grinding influence of microgravity. There was no cement, no soil, just a pile of debris held together by the faintest whisper of gravity. DART didn't flinch. It accelerated. The spacecraft, weighing about 600 kilograms, carried the kinetic energy equivalent to 3 tons of TNT. At 7:14 p.m., the final transmission arrived. The last image was incomplete. The top half showed the rocky ground just meters away. The bottom half was a wall of red static. The data stream had been severed mid-pixel. DART had slammed directly into the center of the asteroid. In mission control, the room erupted in cheers. We had hit a bullet with another bullet. But as the dust began to clear, the telescopes on Earth saw something that silenced the celebration. The asteroid wasn't just nudged, it was bleeding. A massive plume of debris was erupting into the void, brightening the entire system by a factor of 10. NASA's math predicted a polite nudge. They expected the orbit to change by about 73 seconds. The universe gave them a violent shove. When the data came back, the orbit hadn't changed by seconds, it had changed by 32 minutes. This wasn't an error, it was a revelation. We didn't just nudge Dimorphos, we triggered a planetary explosion. Because Dimorphos was confirmed to be a rubble pile, it didn't crack like a solid rock, it behaved like a viscous fluid. This brings us to the beta factor, or momentum enhancement. Imagine shooting a fire hose at a pile of loose gravel. The gravel blasts backwards. That backward blast acts like a rocket engine. DART displaced over 1 million kilograms of rock. This debris didn't just vanish, it formed a tail of dust and rock that stretched for 10,000 kilometers, visible to Hubble and James Webb for months. We essentially turned the asteroid into a comet made by man. The recoil force from this comet tail pushed the asteroid away with far more energy than the impact itself. But the most terrifying discovery came from the burn simulations published in 2024. They suggest that the damage is total. We didn't just dig a crater, we likely unzipped the entire moon. The impact shock wave traveled through the loose interior without resistance, causing a process called granular flow. The rocks inside the asteroid flowed like water, completely reshaping the body. Before the impact, Dimorphos was shaped like an oblate spheroid, like a squashed hamburger. Latest models suggest the impact stretched it into a triaxial ellipsoid, more like a watermelon or a football. We proved we can move a rubble pile, but we also proved that if you hit them too hard, you risk shattering them into a billion pieces, turning a single bullet into a shotgun blast of debris. We learned that these asteroids are fragile, and in space, fragility is dangerous. So what is left of Dimorphos? Is it a reshaped world, or has the surface flowed back together like quicksand, hiding the scar forever? We don't have to guess. We sent a detective. Right now, as of February 2026, the European Space Agency's Hera spacecraft is silent and moving fast. It's deep in the void, closing the final distance to the Dimorphos system. Launched back in October 2024, Hera is the forensic investigator returning to the scene of the crime. But it isn't alone. It carries two shoebox-sized CubeSats named Juventus and Milani. When they arrive later this year, they will perform the most daring audit in space history. Juventus will deploy a low-frequency radar to look inside the body of the asteroid, the first time we've ever scanned the interior of a space rock. It will tell us if the core is solid or void. Milani will scan the dust, analyzing the mineral composition of the crime scene debris. But their final act is the most audacious. Both CubeSats will attempt to land on Dimorphos. This is not a normal landing. The gravity on Dimorphos is so weak, less than 1/1,000,000th of Earth's, that landing is more like docking with a cloud. The landing pads must absorb the shock of a microscopic impact, or else the tiny probes will spin away, lost to the indifferent vacuum of space. If they stick the landing, they will give us the first ever close-up view of a world that humanity has broken and reshaped. If Hera finds a smooth, craterless surface, it confirms our worst fears, that these asteroids are effectively liquid monsters that can heal themselves after an attack. This is the final audit. DART was the punch, Hera is the truth. For 4 billion years, Earth was helpless. If a rock was coming, we simply had to take the hit. DART changed that. We realized that the solar system is filled with these loose, dangerous rubble piles. But we also proved that we have the physics to fight back. We didn't just punch an asteroid. We demonstrated that humanity is no longer a passenger on this planet, We are its pilot. The dinosaurs didn't have a space program. We do. And that makes all the difference.